These are the D45 independent and dependent events guided notes. Independent events are events that do not affect each other. So when you're talking about the probability of two independent events, their probabilities don't have an effect on each other. The probability of the first event has nothing to do with the probability of the second event. As an example, looking at example 1, a coin landing on heads on one toss and tails on another. Explain why this would be independent. The reason why this is an independent event is because the first toss does not affect the second toss. What you get the first time doesn't change or affect what you get the second time. To find the probability of independent events, you need to multiply their probabilities. So you would take the probability of the first event times the probability of the second event. When you see the letter P with parentheses, the P stands for probability, and whatever it says in the parentheses is what you're taking the probability of. As an example, we have a coin that is tossed and a number cube that is rolled. We're trying to find the probability that the coin will land on heads and the cube will land on 4. What you have to do is first figure out the probability of the coin landing on heads. That's 1/2. The probability of the cube landing on 4 is 1 out of 6. You're going to multiply those two probabilities. So for the numerator, 1 times 1, and the denominator 2 times 6, and you get 1 out of 12. Dependent events are events that do affect each other. They're dependent on each other. This means that the first event is going to have an effect on what happens for the second event. As an example, drawing a 4 of spades and a 5 of spades from the same deck of cards at the same time. Explain why this would be dependent. Well, if you draw the 4, it will change the probability of drawing the 5. For example, there's 1 4 of spades in the deck, so it's a 1 in 52 chance of drawing that 4 of spades. If you take the 4 of spades out of the deck, there will now be a 1 in 51 chance of getting the 5 of spades. So the first event does affect the second event. Now we are going to do the D46 independent events activity. You are going to need a spinner, which is divided into 8 parts, and a number cube, which will be given to you soon. You have to determine the probability of both the spinner and the number cube landing on an even number. Using the formula for independent events, what is the probability of the spinner landing on an even number and the number cube landing on an even number? What you would have to do is take the probability of the first event and multiply it by the probability of the second event. The probability of the spinner landing on an even number would be 4 out of 8. The probability of the number cube landing on an even number is 3 out of 6. If we first simplify these fractions, it'll make our multiplication easier. So we have 1/2 times 1/2, and when we multiply those, we get 1/4. So 1/4 of the time, both of these independent events should land on even. We're going to conduct an experiment to see how often this actually happens. So remember, 1/4 of the time is the theoretical probability. Now we're going to find the experimental probability, or what actually happens. What you're going to do is, with a partner, you're going to conduct this test 40 times. So you're going to roll the number cube and spin the spinner at the same time, and keep a tally of the different outcomes. Put a tally mark here when they're both even, here when they're both odd, in the third column when the dice is even and the spinner's odd, and in the fourth column when the dice is odd and the spinner is even. Then you're going to see if it actually does happen where they're both even 1/4 of the time. When you're finished with your experiment, raise your hand and have the teacher check your work. Then turn to the other side to answer the questions on the back.